Hey guys, welcome to Crowns Math. In today's video we want to differentiate a trig function, and one of them is sine x. Now if f of x is equal to sine x, find f prime of x. Okay, solution. Okay, now we have that our from our definition, our f prime of x is equal to f of x plus change in x minus f of x all over change in x. Oh, I forgot the limits as change in x approaches 0. Now this is our definition of f prime of x. Okay, and we want to use this definition to differentiate sine x. So we know that our f of x is sine x, so our f of x plus change in x will be sine x plus change in x. The idea here is wherever you see x, put x plus change in x. So I have sine x, so I'm putting what? Sine x plus change in x. Okay, now remember our trigonometric identity where we have sine a plus b is equal to sine a cos b plus cos a sine b. Okay, so we use the same idea here. So we're going to have sine x cos change in x plus cos x sine change in x. Okay, so now we impute them to this our definition. So therefore our f prime of x is equal to the limit as change in x approaches 0. Okay, and we have what is our f of x plus change in x? This will be sine x cos change in x plus cos x sine change in x. That is for this, minus sine x. Sine x is f of x. Now everything is all over change in x. Now we simplify this. Okay, this is the same thing as the limit as change in x approaches what? 0. Now we have sine x here, we have sine x here. So if I write this, I'll have sine x cos change in x minus sine x plus cos x sine change in x all over change in x. Okay, now this is equal to the limit as change in x approaches 0. Okay, here now this is something as saying sine x cos change in x minus sine x all over change in x. Okay, plus cos x sine change in x all over change in x. Okay, now we are not yet done. So we take this as, this is the same thing as, remember, limit of a plus b is the same thing as the limit of a plus the limit of what? B. Okay, so we distribute these limits. Okay, so we have this as the limit as change in x approaches 0. We have this as let me factorize this one as sine x. Okay, we have cos change in x minus 1 all over change in x plus the limit as change in x approaches 0. We have here as what? Cos x sine change in x all over change in x. Okay, so what we do next is we bring out this sine out. So we have this as sine x, the limit of change in x approaches 0, we have this as cos change in x minus 1 all over change in x plus cos x, the limit as change in x approaches 0, we have sine change in x over what? Change in x. If you observe, I removed sine x out and I removed cos x out. Remember, the limit is based on what? Change in x, and this has change in x, so I have to remove sine x out. The same thing applying with cos x. Now what do you observe? Look at this, look at this too. These are what? Special limits. Okay, it has proof. Actually, this has proof. So these are special limits, and in special limits, the limit of this function, this particular function, is 0, while the limit of this function will give us 1. This has a proof, although we are not going to do it in this video, but take note that this is what? Special limit. So as change in x approaches 0, this approaches 0, and as change in x approaches 0, this approaches 1. Now since this is 0, this will be equal to sine x times 0, okay, plus cos x times 1. Okay, now this will be equal to what? Cos x. So therefore our f prime of x is equal to what? Cos x. Please remember, this has a proof, these two has a proof, they have a special proof to prove it, so they are called special limits. Now I'll plead on you guys to please subscribe, please, because subscribing this channel will make us bring out more videos. Thank you very much. God bless you.